Bismillahirrahmanirrahim. Today we'll talk about the sequential circuits. This is part of the material for digital electronic circuit for the electrical department, Jubail Industrial College. We'll start with the latches, the first element for the memory. Here we have the NOR coupling, and we call it RS. This is active high latch, RS latch. The R for the reset and S for set. Whenever there is a set, that means the Q is going to be equal 1. Set means Q equal 1. Reset means Q equal 0. We will see how it works. Let's test one of these. We'll start with the putting 0 and 1. Here's 0 and 1. And we assume at the beginning that this is 0, this is 1. Q and Q dash should be opposite of each other. So if we have 1, 0 here and 0, 1, then this 0 will come here. So it's going to be like this. 0. 0 with 1 is going to give me a new value. We'll put it in the green to indicate a new value. So 0 and 1 is going to be 0. This 0 will be here. 0 with 0 in the NOR is going to be 0. There's going to be here 1 at the output. If we try one more time, we will see only there is a 1 at the Q and the 0 at the Q dash. This means it's a set here. Okay, let's try the reset. Let me try with the blue color. So assume that we started with the 1 and 0, which is a set situation for the Q, and we will apply 1 at the R and 0 at the S. The 1 here is going to be 1 appears here. The result is going to be in a new color is going to 1, 0, it's going to be 0. Let me put it in the red. This 0 will come here. 0 and 1 is going to give me 0. So again, this 0 is here. We'll try one more. 0 here with the 0 is going to give me a new value of 1. This value, which is 1, is here. With 1 is going to give me 0. Then because of 0 here at the Q and 1 at the Q dash, we call this operation is a reset. Okay. For the no change, if we apply 0 and 0 and assume it was 1 and 0 here, this here is coming here. 1 with 0 is going to give me 0. 0 here is going to go to 1. This one back again here is going to give me again 0. 0 is going to give me 1 again. So there is no change here. Okay? No change. That means the previous value of a Q stay as it is. The present value and the next value are the same. Not allowed is the situation when we apply 1 and 1. Let's see this case. So 1 is here. Going to come here, 1. It's going to be 0, definitely. This 0 comes here. This 0 is going to be going to 0. We'll try once more. So the 0 comes here. 0 will be with the 1 is going to give me 0. This 0 here with the 1 here is going to give 0. So whatever we do, we're going to get 0 at the Q and 0 at the Q dash, which is not allowed or forbidden or inhibit or invalid. The description is invalid for this one. Okay, this is the beginning. Okay, if we do the same thing with the NAND, actually this one is a NAND. You can see here this is equivalent to NAND. Okay, this one is NAND, so it's a NAND coupling, and this active low. The difference between this and active high is when the value at the S or R is 0 is going to affect the output. For example, here we have a 0, so there is a 0 here for the set, and R is 1. So what's happened here? 0. It's a NAND, so it's going to be 1 at the output, 1 here. So it's a NAND again. It will be 1 at the output. This one will come again here. This one at the NAND is going to produce 0. This 0 comes here. 0 is going to be 1 here. So the value at the Q is 1, at Q dash is 0. It means a set operation. And so on, reset and no change and invalid. The invalid here is going to give 1, 1 instead of 0, 0. The next slides will show you the truth table. So you can go through them and see them one by one. This is the way how we check the latch. So the active low is the coupling of NAND, and the active high is the coupling for the NOR. And remember the meaning of active low or active high. Active low means 0 is affecting the output, and active high means 1 is affecting the output. I provide here the truth table for both of them. Let's start with SR, active high, or RS. Okay, so 0, 0, no change. That means previous value is the same as the new value. 0, 1 is 1 for the reset, so it's a reset here. Reset means Q is 0. If we put 1 here at the S, it's going to be a set. Q is 1. And if we apply 1, 1, it's invalid. It's going to produce 0, 0 as we illustrated earlier. Okay. For the active low, SR, so 0, 0 means invalid here, and the output is going to be 1, 1 at the Q, as we mentioned. If we apply 0 to S, this is a set, so Q equal 1. If 0 at R, then it's going to be a reset, 0 at the Q. If we apply 1, 1, it's a no change here in this situation. In this diagram, we illustrated two timing diagram. Suppose that we have S and R, and we need to complete the waveform diagram. We should assume at the beginning that Q equals 0. Most of the time we're assuming that, so it begins with 0 and 0, as you can see here. 0 here and 1 here, which is the opposite. Beginning is here, actually. Then let's see. We apply 0, 0, 1, 0 here, and 0, 0 here, 0, 1 here, 0, 0, 1, 0, 1, 1. Okay, so in order to draw 0 and 0 means no change. That means Q's stay as it is. This is what we show here. 1, 0 means is a set, so it's going to be high. This is the set. This is the set situation here, as you can see. This is set. 0, 0 means no change, that the set it will remain on here. Then 0, 1, which means reset, so it's 0. 0, 0 means to keep the same thing as no change, so 0 is continue here. Back again to set, so So it's set, which is 1. Then when we apply 1, 1, this situation is the invalid situation, so it's going to produce 0, 0, which is, you can see it here. Of course, Q dash is the opposite of Q. So if this is going like this, definitely this will go like that. And because of the last one is 0, 0. Remember that this is invalid. Active low, beginning with 0 for the Q. Q dash will be 1, of course. We started with the 1, 1, which is no change. That means to keep the same thing, 0 here. Then set, so it's 1 here. Then here, no change again, to keep the set 1. 1, 0 means reset, which is 0. No change, keep the 0, keep the value the same as the previous one. 0, 0 is the invalid case, so it's going to produce 1, 1, and this is what I'm showing here. So please read this here, and you have the PDF file where you can look to them again. SR with enable. What we add here is this circuit to allow the enable. What's the enable? Enable, if the value is 1, then the circuit will work. If not, then there is no function for the circuit. The circuit will not function. Well, usually we need enable for organize the signals when we have more than one IC. So this is enable used there as to enable the chip itself. Here a diagram with the enable. Whenever enable is equal to 1, then the function will be as we illustrated before. And we have here active high SR. So remember the active high SR truth table. Okay, so 1 here, you apply 0, 0. That means no change from previous case, so it's going to be the same like here, 0 and 1, so it will be 0 and 1 again. Then we have to keep going till the next enable. There cannot be any change during the enable equals 0. There is no change at all, nothing here. Just before the next enable, there was a value of 1 and 0. That means there is a set, so it's going to be set here. This set will continue till the next enable. This is very important to notice. Here we have 0 and 1, which is a reset. So it's going to, it says 0. It says 0 and 1. This is 0, 0. This is confusion. 0, 0 is no change, so it will keep the 1 here. We move on to the next enable, which is here. We're going to see 0 and 1. This is a reset, yes, definitely, 0 and 1 here, the opposite. Then the next one going to be 0, 0, which is no change. And then 1 and 0, which is set, so it's going to be set. And then just before the enable here, it was the value of 1 and 0, which is going to be set, so it's set again. Okay, read here and see. Okay. D-latch. This is the D flip-flop or D-latch. Adding to the circuit of the previous one, which is here, we can add this connection between the S and R. Inverter. What it means? S and R, between them an inverter, means they have only the values of 0, 1 or 1, 0 for the S and R, which is set or reset. Nothing else. So this is simply how it is. This is the D latch flip-flop. You can see the truth table here. Inputs. Only when enable is working, we're going to see the output. Otherwise, it's no change in the value. So if we apply 0 at D, then we get 0 at the Q. If we apply 1 at D, then we get 1 at the Q. Always Q follow D. Whatever the value of D will appear at the output when there is enable. You see here, this is very clear. If enable is 0, so it doesn't matter what's the value of D, it's don't care. The output is going to be no change at all. Waveform diagram. Enable, very important, when enable is 0, there is no output, no change. So the value here, for example, let's see here the value 1, enable is 1, then the output is 1. Okay, value is 0, enable is 1, then 0. Okay, the same. But when there is 0 enabled, so there is no change here in this area. So no change, it's 0. Then enable is 1, and the enable is 1, value is 1, then the output is 1. Enable is 1, value is 0, then the 0. But when enable is 0, there is no change of this value. It will keep the same. Okay, so if there is enable 1 and 0, then going to be 0. Enable is 1, and there is 1 is going to 1. So this flip-flop is just like a mirror. When enable is equal 1, whatever the value in D will be transferred to the Q. Okay, before going deeper, we call them flip-flop. The flip-flop is the same like what we mentioned in the latch, but here we're going to add the clock. A flip-flop is an edge-triggered device, which means that the output is sensitive to its input only upon an active transition edge on the triggering input called the clock. CLK is for the clock, and this is what we call it a transition. This is a positive transition, and this is a negative transition. This is the leading edge, and this is the trailing edge or failing edge. Very important. If we have this symbol, means this clock is working in the positive edge. Okay, if this symbol means the clock is working on the negative one. Okay, so this is for the positive. You can see it here, and this is for the negative. This is very important notes. This circle here means the Q dash. This is the opposite of Q actually, and this is Q dash. Okay, so we have either a positive one or negative edge triggered or positive edge triggered. This is the two values. Let's see the waveform diagram, but before that we see the truth table. Truth table. It's again S and R, and only works when there's a positive edge. We're talking about this here. So this is here. So when there is 0, 0, doesn't matter about the clock is coming or not, there's a no change. This is no change case. But if there is 1 at the reset, so it's going to be a reset when the clock is arriving, the positive one, positive edge. When 1 at set, so it's going to be a set under the control of the clock. When it's positive, 1, 1 means is invalid. So this is the values is going to be the same. That's why we call it invalid. X for the don't care. This is for the clock, and the don't care for X. Here is the waveform. Remember that the changes happen only on the edge. This, in this case, is a positive one, positive edge trigger. Okay, look here. We have S and R. There is a 0 and 0. So already we begin with the 0 here, but the beginning should be here at this clock. When a clock arrives, there's 0, 0, so it's no change at this area. This is no change, will take an effect from this clock to the next clock. There's no change between them at all. When arrive at the next clock, it will check what are the value before. So it was 0 and 1 here. So it's going to be a reset. So it will do a reset. This will continue till the next edge when it's 1 and 0. So it's going to be set. So it will do a set till next clock. Then before the clock, just before the clock, sorry for drawing it here, it should be 0 and 1 here. So it's going to be a reset, which will be here till next clock. Here we have 1 and 0, which is a set. It will do the set till next clock. Here is we have a 1 and 0, still continue with the set. And this is how it works. Remember this. Change only on the edge. Here, positive edge. Okay. Continue. This is just an exercise from the book. Draw the Q output for each flip-flop if they are initially reset. We will have the output for this clock, which is a negative edge, and for B is a positive edge, and we need to find out both of them. I choose the red color for the negative and the blue color for the positive, and let's see. Now please follow the blue with me, and we're going to see how it is. So beginning 0 here and 0 here. For this Q and this Q, both of them we begin with the zeros. But for the blue one, it's a positive edge. If you have 1 and 0 here, means it's going to be set. So it's set till the next clock. This is set till next clock. Now here there's a 0 and 1. So it's going to be a reset. So it's reset here till next clock. So there is a 1 and 0 here, means a set again. So it's set. 0 and 0 means no change. So no change here. Blue 1. Remember we are doing the blue. 0 and 0. So no change again. That's it. Now we're going for the red one. Follow the red. The negative edge, which is here. 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 And here. For this one, just before the clock, the negative edge, it was 1, 0, so it's a set. So beginning is 0, but it's set here from red to red till this clock. It's going to be 0, 1, which is a reset, so it's a reset. Going to be here before the clock 1 and 0, so it's a set, it's set again. So 0 and 0 is going to be no change. And now the last clock is 0 and 0, no change again. And this is the summary how we complete the waveform. This is for the positive one, the blue, if you remember. This is the blue one. Let's see the blue one first. The positive edge, it was 1, 0. So it was 0, the Q. Then it's because of the 1 at the set, so it's going to be set till the next clock. 0, 1 before the clock, immediately before the clock. So it's going to be a reset, so it's a reset. 1 and 0 before the clock, so it's going to be a set. 0 and 0 is no change here. And 0 and 0 before the clock, so it's when the clock arrives, it is going to be no change. We go for the red one. So what we see here is 0 at the beginning. 0 will continue because the edge, this is not affecting. This edge is not affecting, so it's not going to affect. So it's going to be 0 here. Just before the effective edge, which is negative 1, 1, 0, which is a set. Then the next clock, 0 and 1, so it's a reset. Next clock, 1, 0 before that, so it's going to be a set. A 0, 0 means no change. 0, 0 again means no change. That's it for this one. this is the two kind of D flip-flop. The first one, the clock is positive edge trigger or negative edge trigger. And always here we show the positive edge like one arrow pointed to the top. This is the arrow like this. Okay. So 1 at D will appear at the Q if there's a clock. If there's no clock, that's another story. It's going to be no change. 0, it will give 0 at the output. Always remember Q follows D. Whatever in D will be transferred to the output Q when the clock is applied. Here's this only the same truth table, but only we have the negative edge. Negative is pointed like this. Okay. Waveform diagram. Here is the point. Q follows D. So D is 1 just before the clock, then it's going to be set here till the next clock. 0 at D means the next clock will make it a reset here. 1 just before the clock, then there is a set here. 0 here means a reset here when the clock is arrived. The edge triggered JK flip-flop, it's 2 input J and K, and there is a special construction for that. They build it from the SR as well. This is edge trigger means when we call it flip-flop, there is a clock here will control this. It's similar to SR flip-flop, however, don't have invalid state. They avoid the problem of invalid state, we talk about it. And instead of invalid state, in the case of 1-1, we have something called the toggle, the opposite of the state. This is the new gate. When J equal K equal 1, the output state will be inversed upon the active clock edge. When it will be invert of the current state, it will be inverted. So if it was 0, it's going to be 1. If it was 1, it's going to flip to 0. The truth table for negative edge triggered flip-flop is here. This is the truth table. Okay. 0, 0 at J and K means no change, like SR. 0 at J, 1 at the K means 0 at Q. Always Q the same value of J. So Q follows J to remember the value. Q follow J. See here, J is 0, Q is 0. J is 1, Q is 1. When we apply 1, 1, it's going to be a toggle. So 0 at J means reset. 1 at J means set. And so on. The truth table is already giving. Here is the waveform diagram, and we need to see. Remember, from clock to clock, this is the positive edge clock. You see here how it's going up. Okay, now see here. We have 0, 0, beginning with 0 for the Q. 0, 0 before the clock means no change. So there is no change here. 0 remains. If we apply 1, 1, it's the opposite state or toggle. Toggle means if it was 0, it will going to be to 1. So this is changed to 1, the opposite. When there is a 0, 1 here, means reset. So it's going to go 0. 1, 0 here means a set, so it's going to be 1. 1, 0 again means a set, so continuation of the set. When it's 1, 1 is a toggle, so it's going to go down to 0. This is the toggle. Okay, when there is a 0, 1 at the end here means is a reset, so it's going to be a reset, and so on. This is the extracted from the truth table above. Always try to remember the truth table. This is very important. Okay, we are close to the end of this session. Here we need to, this is example for you here, and this is just illustrated because the solution is given. Determine the Q output, assume that the flip-flop is initially reset. Flip-flop is 0 at 0. This is a negative edge, so expect it to be like this. So there's 0 at the beginning. Then look here, this is a negative edge, so it means 1 and 1. This is toggle, it's going to go 1. And just before the negative edge here, there's a 0, 0, so no change, so it will stay at 1. And here is we're going to have a 0 and 1, which is a reset, is going to be 0. And here, before this one was 1 and 0, which is a set, so it's going to be 1. And just before this one, there is a 1 and 0, which is again a set, so it's 1. Very clear, okay? Now, what we do here is the same thing for this one. We have this. So there is a set here. This set from 1 and 0. Again, here 1 and 0, which means a set again. So it's going to be a set till here, set. And then there is a 1 and 0 as well, so it's going to be a set. So 3 sets continuously, but at this point there was a 1 and 1, which is a toggle. This is a toggle here. So it's going to be opposite, which is 0. Here is 1 and 1 is another toggle. So from 0 going to 1. Here is another 1 and 1, so another toggle. So it's going from 1 to 0. The end, 1 and 0, which means a set, so it's going to be set. And that's it. This is how it looks like. This illustrates the complete JK flip-flop with the preset and clear. What's the job of preset? This is very important before we begin. So when preset value, they are active low, both of them. They work only when it's 0 because of the notch here of the circle. That means they are active low. So whenever preset equals 0, the Q will be equal 1. This, they call them asynchronous input. This is asynchronous input. Asynchronous means they are not following the clock. They are not waiting for the clock. They disrespect the clock. So when clear is equal 0 as well, the Q is equal 0. So this is for clear and this is for preset. Preset means 1 at the Q. Clear means a 0 at the Q. Okay. JK asynchronous input, preset and clear asynchronous input they call it. This is asynchronous inputs. Low, active low, both of them, you can see here. And let us see the function. When preset and clear is equal to 1, 1, both of them, they should be 1, 1. So they're a normal function for JK flip-flop. This is a normal function. Any one of them equal to 0, this is abnormality, which is asynchronous input interference, so the clock will not be respected here. So look here, when there is a 1 here and 1 here, normally the JK will function properly as before. So there is a 1 and 0 here, which means set, so it's set here already. Okay, then there is a 1 and 1 here, which is a toggle, so it's going to go from 1 to 0. This is 0 here. But here we have a 0 at the preset. So we will leave the clock now and we're going to implement whatever we find here. So what will happen at this point, effective point, it's 0 at the preset means Q equal 1. So the Q is set, asynchronous set we call it. This is going to be equal 1. Okay, because it's going back to normal, then we have to watch for the clock. The clock here, before the clock was 1, 0, which is a set. It's going to go set again. Normal, because there is a 1 here and 1 here, it's normal. So 0 and 1 again here, the clock is function, so it's going to be a reset. When there is a 1, 1 here means a toggle, so from reset is going to toggle, means going to 1 because it was 0. But here we have interference of the asynchronous input. Whenever the asynchronous input is coming, then the clock will be no function for the clock at all. There is no respect for the clock. So when it's 0, clear 0 means Q is 0. So the Q is 0, equals 0 here at this point. it's a reset. We call it a synchronous reset. But because it's going back again here, the clock will wait. This is the waiting time here. Before the clock, nothing will happen. Okay, it will stay reset till there is a 0 and 0, which is no change, and then there is no change here. This is how the waveform are working for this one. Again, another one. Positive edge. We said when preset and clear are both of them equal 1, so there is the function for the clock. This is the time where the clock is working. This is the area where the clock is working when it's 1 here and 1 here. Otherwise, when preset is 0, what happened? Q is 1. Here, when clear is 0, clock is Q is 0. When there is a 0 in the clear, that means Q is cleared 0. Otherwise, everything will be function as normal. See here, when there is a 1 here and this is a JK. Oh, this is just to illustrate the area where the preset and clear are working. So in this time here, if the J and K are working, J and K are connected to 1. So forgive me for this one. I just forget that it's 1. When it's 1, that means J and K is doing the toggle all the time. Toggle. When there is a clock, it will be a toggle. So it was, the value was here at 1. So the should, here the value is 1 and 1. The value at the beginning was 0. So it will toggle the value. So because there is somehow the Q equal 1, because of this, the Q equal 1. When the Q equal 1, toggle means it goes to 0. Another toggle, whenever there is a clock, it will go 1. Another toggle, opposite to 0. Another toggle is opposite to 1. Till this moment when the clear is interfering. So again, this is the area of the toggle. Why? Because we are connected 1 and 1 here, and the Q value was 1 at this point. So from 1 to 0 to 1 to 0 to 1, and that's it. Okay, another diagram here. Okay, this illustrates that if we have two flip-flops, we're going to have a frequency divider. This is frequency in, and this is frequency out. See the QA, and then the output here. So this is a divide by 2, and this is a divide by 4. We will see more details about this when the time comes for that. But this is a frequency divider. Flip-flop applications. Okay, here's more details about the frequency divider. Determine the if out waveform if and if n equal 8 kilohertz square wave. This is 8 kilohertz is coming from the input, and we need to watch for the frequency here. So 8 divided by 2 for the first flip-flop, which is 4 here. Then this 4 divided by 2, okay, and divided here till we get the 1. So it's from 8 to 4 means divide by 2, 4 to 2 divide by 2, and divide by 2. Okay, so every time it's got divided by 2. 8 became 4, then 2, and then 1. So we're going to see 1 kilohertz here. This is one of the application. Another application is, I believe this is just like a counter. Even that one in the top here is a counter, actually. It's count from 0, 0, 0 up to 7. It's mod 8 counter, we call it. Determine the output waveform. This is the waveform here, 0, 1. This is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, back to 0, back to 0 here. Okay, so thank you. Okay, this is the practical part. Just follow and enjoy. This is the construction for the RS flip-flop, the active high, active low. Please just follow and see. It will be very easy to understand.